are leveling something called free fall. We have something called free fall. So, definition. Another thing in order we talk about physics, to understand the definition or so more like a free fall. Like a emotion. Let me do this. Emotion on which the only force acting on an object is gravitational force. A motion on which the only force acting on an object is gravitational force. What are like a free fall? Like a situation where or an object imomoye or one mologoro my imomoye object in I want other force iloria actable. Act is again gravitational force. And gravitational force always pulls the object downwards. Then we have something called projectile. Definition of projectile. It says it's an object that has been given an initial velocity and the object, it moves under the influence of gravitational force only. Another definition is again, projectile is an object that travels through the air while gravity is the only force acting on it. There's another definition. It says projectile motion is an object that travels through the air. Through the air. When the only force acting is of gravity. An object that travels through the air, whereby the only force acting is of gravity. Or more like a free fall, we're talking about a motion. And in that motion, for the object to do that particular kind of a motion is due to gravity. And when like a projectile, like an object that travels through the air, whereby the only force acting on it is of gravity, where everything is influenced by something called gravitational force. And if there is gravity, then we have to talk about something called gravitational acceleration. Gravitational acceleration. Acceleration. So we have to talk about gravitational acceleration. That is very, very much important. So with gravitational acceleration, its definition goes as follows. Definition. They're saying gravitational acceleration is the constant acceleration of a free falling object due to gravity. Is the constant falling, free falling object due to gravity. So, in other words, again, for gravitational acceleration to exist, is something called what? Gravitational force. So, gravitational acceleration is given by G, just a small energy. And you have to know gravitational acceleration is what? It is a vector, meaning we have to take in consideration direction immediately we are making use of it. And another thing, again, it is always downwards. It is always downwards, meaning gravitational acceleration, if the fast, as gravitational force is always towards the center of the earth. Then another thing, again, gravitational acceleration on earth is equals to 9.8 meters per second squared. And gravitational acceleration on the moon is equals to 1.6 meters per second squared. Yellow Rosanzo is even much 9.8 meters per second squared. If you want what do for this one? So yellow Rosanzo is by heart is 9.8 meters per second squared. Then I know I really learning the formulas. We have formulas, projectile motion. It's an engineer, but we have to know them. But obviously, what do you call formula sheet? They will be there. So, formula mathematical again. Final velocity is equals to initial velocity plus acceleration multiplied by change in time. Remember, velocity, final velocity, initial, they are vectors, meaning direction has to be taken into consideration. And direction can either be negative or positive. This is very much important. Then acceleration is also a vector, and the direction has to always be taken into consideration. That's the thing. Then we have another formula which is like this: VF squared, final velocity squared, equals to initial velocity squared plus 2a change in y, which is the displacement. First thing we get displacement, the change in y is the displacement. Displacement is also a vector, meaning it has a direction. And direction I want to mention direction of velocity, the acceleration. So in order, if velocity is right, change in x, it also goes right. If the velocity is going up, change in y also upward. If the only changes more, or again, acceleration now, it shall be replaced by gravitational acceleration. So that is the only difference in vertical projectile motion. Or acceleration now, it replaces again gravitational acceleration. Why? Because the object is moving more, and the only force that influences that particular motion is gravitational force. And from that instance, gravitational force generates gravitational acceleration. So this one is a gravitational acceleration, meaning it's always constant as 9.8 meters per second squared on Earth. On the moon is a different number, but rather on Earth. So basically, which means we'll be dealing with problems pertaining Earth. Then we have another formula which says change in y is equals to initial velocity multiplied by change in time plus 1/2 acceleration change in time squared. Then another one is change in y is equals to initial velocity here, no. What is this? The same is equals to velocity 1 plus velocity 2 divided by 2 times change in time. Here formula it doesn't work. And this one. The most important ones is 1, 2, 3. And the other thing you know, which SI units, would substitute the values in that particular SI unit. Basically, if give velocity in which unit, substitute more the answer. Then more again, where VI is initial velocity. And your initial velocity is always in meters per second. If we're filling kilometers per second, convert that particular thing into meters per second. So which means you have to know them. The final velocity is what? This is final velocity. Velocity. As long as we velocity is measured in meters per second. Then we have change in y, which we call it displacement. Displacement goes hand to hand with something called direction. But the only thing is just that we take the final direction and minus it with the initial direction. Because, yeah, that's displacement. Displacement basically is equal to y2 minus y1. This one, it just means that like something, it is moving vertically. But in something that is moving horizontally, changing displacement will be talking about, displacement will be talking about x2 minus x1 over x final minus x initial. Here you can say final minus initial. Then another one will be having A, which is acceleration. Acceleration. Acceleration is always in meters per second squared. Acceleration baka go fa yo. Mara o ba sa go fa acceleration mohotsi. No gore aba expect gore in vertical projectile motion works like this. If about acceleration, so shumishe 9.8 meters per second squared. So yeah, if about acceleration, so shumishe this one. Mara, there is a situation whereby an object can move in the air, but without complying with the laws of free fall. Yellow I apply with the laws of free fall, that means there is another force yellow is exerted. Alternatively, fly machine over a rocket. Rocket it's under the influence of a certain force. Yellow range, drag force, whatever. That one. Influence like that one. Basically, the engine applies a force on the rocket or then from that instant acceleration but if an object just falls, acceleration it will represent again 9.8 meters per second squared. Then again we have change in time. We know time is always in seconds. Always time is always in seconds, doesn't change. Then we have another thing that we have to note. You have to note what again? Gravitational acceleration. Acceleration is always downwards. Fast, that is gravitational acceleration is always downward. That means what? If downwards is positive, downwards is positive, then your gravitational acceleration it will be positive. If upward is positive, that means gravitational acceleration is negative. Because gravitational acceleration always opposes the motion. If object negative and negative positive, gravitational acceleration becomes negative. If an object fast and fast again in negative, oral gravitational acceleration also takes that particular direction. Because if it is fast, that is gravitational acceleration is always pointing downwards. gravitational acceleration, always pointing downward. Then the graphs of projectile motion. Graphs of a projectile motion. We'll be looking at graphs of projectile motion. The graphs don't really say like by heart. Or if a situation is like this, trial motion. Those are the graphs of the projectile motion. The type 1 of the graphs I think it's 5 of the graphs. So type 1 again, dropping a projectile. Dropping a projectile. Dropping a projectile is like dropping an object. Mover in the air. It over influence again gravity. Dropping a projectile. So here again, when the projectile is dropped from rest from a certain height, initial velocity, it will be equal to meters per second. When a projectile is dropped from rest, there was no other force applied. If an object is dropped from rest, then initial velocity, it will be equal to 0 meters per second. For example, maybe there is this guy standing on top of whatever, it can be whatever, a hill or something. Then I drop what we call a ball. Initial velocity of this ball is equal to 0 meters per second. Always is equal to 0 meters per second. Then the velocity increases when the projectile moves downwards. Basically, the velocity will increase as the object moves downward. Object move downwards until it reaches a maximum velocity. So when an object it is being dropped from 0, velocity increase as the object until it reaches the ground level. When it reaches the ground level, it will reach the ground level at a maximum velocity. It can be 4 meters per second or something. But the velocity is a maximum as the object hits the ground. That is what I was saying. If velocity, basically, if an object at a zero velocity, that means an object it will increase in velocity. When it hits the ground, when it hits the ground, it will hit the ground under a maximum velocity. Because velocity it increases as the object goes down. And the thing that causes the object to increase in velocity as it goes down is gravitational force. Then again, if gravitational force, if a projectile or an object is thrown downward, if we throw an object downward, its initial velocity is no longer 0, its velocity its initial velocity is not 0. So in simple story, initial velocity is not equals to 0, but the initial velocity it will be equal to the velocity at which the object is thrown downwards. So if we have another guy here, then this guy and run throw an object downwards with a force. This object, its initial velocity is not equals to 0. Why? Because an object was thrown with a force, and that force will result into the generation of velocity. Then, when we talk about velocity, no, what are velocity? It will be greater than 0 meters per second at this point when the object is being thrown downward. The initial velocity is the velocity at which the object is being thrown downward. More with an object, we beat away mama sign. Downward. Initial velocity is zero because the object was not at the rest at that point. You were throwing the object. So this one, it was dropped. When they're talking about an object being dropped, you should always take note that they are telling you that the initial velocity is 0. If they're telling that an object is being thrown, they're telling you that the initial velocity is not equal to 0, meaning the initial velocity changes from 0 to a certain amount. We don't know, but it will be equal to the velocity at which the object is being thrown. That is what is happening in projectile. Then again, there's something else before directions. That's why we like a vertical. The reason why we are giving vertical projectile is because reliability, an object that moves vertically, it can either go up, it can either go down. Then in terms of direction, you choose my scatter, like you have a choice. Or upward is positive and downward is negative. Or if upward is positive, then downward has to be negative. If or if upward is negative, then downward has to be positive. The direction is always like that. It doesn't change. It is always like that. So what is happening is, but if you choose downward as positive, if we can say downward is positive, right? If we choose downward is positive, which means our down is positive and our up is negative. That means our initial velocity when we drop an object, 0 meter per second, dropping an object. This one, when we drop an object, the initial velocity is what? Is 0. But when we throw it, an initial velocity is not equal to 0. Then move. Final velocity, it will be equal to positive max, which means it will be positive velocity. But it will be maximum. Why? Because if we have a guy, a dropper, an object, remember when we drop, I said more allowed drop. Initial velocity is 0. So here initial velocity is 0. Then when the object reaches downward, it will reach downward with a velocity that is maximum. That is why we said positive max. And for that instance, it takes a positive sign because when it's going to hit down, it otherwise will be velocity downward. Then again, change in y, it will be positive. Why? Because displacement takes on the direction in which the object is moving. If the object is moving downward and downward is positive, displacement becomes positive. If the object is moving upward and upward is negative, that means our change in y, it is going to be negative. Then our change in time, this one, RZ, we don't know it. Then again, we will be having acceleration. Acceleration, because the object is being dropped and is moving downward, and we said downward is positive, then it's going to be a positive 9.8 meters per second squared, always like that. Then again, if we choose let me change the color. If we choose, we drop an object again, and if we choose upward, again, if upward is positive, that means direction arrow is going to be like this: positive upward, negative downward, and we drop an object. Initial velocity is equals to 0 because what? The object is being dropped. If it is dropped, initial velocity is 0. Then again, final velocity, it will be equals to negative max. This negative sign, which our final velocity, it is going downward. Then again, change in y. Give the change in y, which is our displacement, takes the direction in which the object is going, and the object is going downward, then to be negative. Change in time, we don't know it. Then again, when we're talking about acceleration, as long as we remove my object, I wanted the other force act out. But the only force will react is gravitational force. Acceleration is in negative 9.8 meters per second square. Why? Because acceleration is always moving downward of gravity. Gravitational acceleration is always moving downward. It's always implies to be fast. Then it always take a downward direction. That is how these things works. Then, in terms of graphs, let's look at graphs. In terms of graphs, sometimes this graph here. So, more we're talking about dropping an object. Case situation lower, an object is being dropped. Then we have displacement or position. Good displacement in position, versus time. Good displacement, the position, the distance. It's just that displacement reminds the final distance, the initial distance. Then move. But again, if downward is positive, if downward is positive, then we have our y, we have our time. If downward it is positive, our graph is going to be like this. Remember, if downward is positive and up is that, change in y is equals to y2 minus y1. If move to -1 and here it is 0, then the ground, when we drop an object, the ground is regarded as a reference object. It's regarded as a reference point. Is a point where displacement is 0. So what again is equals to moga final, moga initial, 0 minus and -1. We get a positive change in 1. That's why our graph becomes like this. But if downward is negative, our position versus time graph is going to be like this. For example, changing y, let's again, if downward is negative and upward is positive, changing y is equal to y final minus y initial. Y final is always 0 because it's at this reference point. Then here we have a value maybe of 2. It will be 0 minus 2, which is equal to -2. You see, so it has a negative direction when it is above. So I'm talking about again, if downward is positive and the object is moving downward, that means the graph be like this. If an object is being dropped and is moving downward and downward is negative, it takes this form. Always know that by heart. Then again, when we're looking at velocity versus time, velocity versus time graph. This one is one of the easiest. It's very simple. If an object is being dropped, remember, dropping an object. Gormo, object they are dropping. That means we have velocity, we have time. In this situation, remember what above is always positive, down is negative. So, roll again. If an object is dropped and downward is positive and upward is negative, and an object is moving downward, that means our velocity, it will start from zero, because initially when we drop an object, it has a zero velocity, increasing its velocity like that. Then this, it will be your velocity against time graph. Then again, if we have a velocity versus time graph, but our downwards is negative and our upward is positive, and an object is moving downward, that means our velocity graph is going to be like that. Because, and again, what's worry more? You know, trying to Cartesian plane. We know what at the y is positive, here is positive, here is negative, here is negative. Take gamma, negative, then velocity Nigeria a negative sign. Gamma, positive, positive gamma. So the velocity Nigeria a positive sign. That is what is happening. Then when we drop an object and level acceleration versus time. This one is one of the easiest. Yeah, ntrelo ya change. Okay, ntrelo bitaur again. Sine fair. If here's an acceleration, here's time, and if an object is being dropped and moving downward, meaning our gravitational acceleration takes what? A positive sign. That means it overcome. Then so because it is constant. At a positive part of the Cartesian plane. And again, if our acceleration is there and we have time, and the object is moving downwards, and downwards is negative, then our acceleration is going to be in the negative part of our graph, which is downwards, like that. Then, yeah, that is all about dropping an object. So, I want us to do an activity. In this activity, but again, we have a ball of 200 grams from a roof of 100 meters height. So basically, we have a roof. This roof, it has 100 meters height, 100 meters height, and there is a ball there. Then with this ball is being dropped, a ball of mass, 200 grams, is dropped from the roof. Then we drop this object from the roof, dropping. And again, if we're talking about dropping, that means our initial velocity is equal to 0 meters per second and is dropped downwards. Then the question says, calculate the velocity of the ball when it hits the ground. So out of all the formulas, check out give you a lower direction B. Downwards is positive and upward is negative. Direction is yours. Like we choose a color or we choose a one. Remember, varifile displacement, which is 100 meters, reserve initial velocity. So out of all these formulas, which one is better? Varifile this one, which is 100 meters. This one rises again 9.8 meters per second squared. Then Rene initial velocity, and we need to find final velocity, which is the velocity at which the object hits the ground. Then Roshumisha this formula, because here we don't have time, so we cannot calculate. This one we don't have time also, this one we don't have time. Then we can only use this one. Then roll again. Here, we're going to say VF squared is equal to VI squared plus 2 change in 1. Then in this situation, again, final velocity is Vf squared, then initially 0 squared, because we're dropping the object. When we're dropping the object, velocity becomes 0, plus 2. Remember, G is our gravitational acceleration, and gravitational acceleration is 9.8 meters per second squared. And downward is always downward, and downward is positive. Then it's going to take a positive sign. Then here, changing y is 100 meters. We're going to write it as positive because the object is going downward, and this one always goes hand to hand in the direction in which the object is going. Then our VF squared, it will be equals to root of 2, 9.8 times 100. Then our final velocity, it will be equals to 44.27 meters per second. Because it's positive, what are you guy? Downwards. Right. More substitute is a positive because it's superior downward. More is a positive answer because final velocity like we get the object reached its final velocity when it was moving downward. Then this one is positive because it's going hand to hand with the direction of an object. If an object is moving downward, changing y is also moving downward. If an object is moving upward, changing y is also going upward. And directions is goes hand to hand with how you regard the direction. So in this situation where the object is moving downward and change one is downward, that means we're going to have a positive direction and negative direction. Then change in y is equal to positive. Then here, change in y is going to be negative. If our upward is negative and downward is positive, it will take this sign. Then a class work in order to iterates all about dropping of an object. Then we're going to calculate something else. Then from there, I will send a link rather corrections. It's just one question. So what are by half past the dual figure? We send our group.